Okay, so we have this question here. You said in your email someone mentioned a t-table. You can use a t-table if you were going to do this by hand, but we're going to use the calculator to do all that for us. So there's no need for a t-table. Basically, this comes down to your choice of three operations in the calculator, and that really depends on what you're looking for. First thing, if we're looking for a confidence interval for the mean and sigma is known, let's say we know the population standard deviation, that's going to imply we're going to do a z interval. The other option would be that sigma is unknown. We don't know the population standard deviation. If that's the case, we're going to use something called the t-interval. If you want to read more about why that is, that's in our PowerPoint notes. And then if we're talking about a proportion and not the mean, this is going to be a one prop z interval. Okay, so every single problem in this chapter, you're just going to use one of these three operations. And whether the data is given to you in list form or given to you as statistics, that's going to change the way it's inputted. So this says in 1998, an advertising campaign, the Nabisco company announced the 1,000 chip challenge, claiming that every 18-ounce bag of their chips contained at least 1,000 chips. Dedicated statistics students at the Air Force Academy, note this really happened, I guess, purchased some randomly selected bags of cookies and counted the chocolate chips. Some of their data is given below. Find a 95% confidence interval for the mean number of chips. So we're looking at one of these two. But nowhere in this problem does it tell us the standard deviation for the population of all Nabisco cookies. So in this case, it looks like we're going to use a t-interval. But notice the data is given to us in list form. So before you do anything else, you're going to go to your stat list. You're going to edit, clear out everything you have, up, clear on the L1, enter. And I'm going to input this data. I'll pause the video real quick just so you don't have to watch me input all the data. Okay, so I have all my data in L1. And now I said we're going to use a t-interval. So I'm going to go to statistics, over to my tests, and I'm going to do a t-interval, which is option 8. And now I'm inputting data. So I'm going to highlight data above. The list is L1. They all have a frequency of 1, and my confidence level is going to be 0.95. So this is going to be from 1187.9 to 1288.4. There you go. Okay. Number 2 says you intend to estimate the population mean. Okay. So you believe the population is normally distributed. Find a 99.5% confidence interval. Let's see here, accurate. So there's no mention of sigma again. So this is going to be a t interval as well. Let's see if I can just input these real quick. Oops. Okay, same thing, stat. Over to tests, we're going to do option 8. Data, and now we want 99.5, so 0.995. 2 decimal places with parentheses. So this will be 32.21 to 62.61. Just like that. Okay, and the last one, assume a sample is used to estimate a population mean. Mu, find the 99% confidence interval for a sample of size 35 with a mean of 68.9 and a standard deviation of 6.3. Okay. Okay. Whoop. So it says assume that a sample is used. So first thing you want to check is sigma known? Does not mention anything about sigma, so we're going to use a t interval again. But now the data is given to us in forms of statistics. So we're just going to go to stat, over to test, down to t-interval. And I've already put it in there for us. The statistics they give us is that the sample mean is 68.9. So X bar is 68.9. The sample standard deviation is 6.3. This is not the population. N is 35. And we calculate a 99% confidence interval. So accurate to one decimal place, we get 65.99. So 66 to 71.8. There you go.